Hey guys, I need a better intro than hey guys. If you think of something, put it in the comments. We need to answer questions 26 through 31. Those next 6 problems, there's 6 problems that I put together in no particular order that are different types of neutralization reactions, and you have to be able to figure out, which way you're going to calculate it. We've talked about a lot of different ways. Sometimes you use Henderson-Hasselbalch because you make a buffer. Other times you don't. So we're going to take a look at those. If you haven't solved number 26 now, pause it and try and solve it. Okay, so let's take a look at this problem. If I've got half a liter of this HCl solution, and I've got half a liter of this ammonia solution. HCl, of course, is a strong acid. That's a strong acid. And NH3 is a weak base. And I know that because I know it's not a strong base, and I also know it because it has a really small Kb. So I've got a half a liter. So I'm going to make a Chewbacca table. All right, there's my BCA. I'm going to have my HCl. I'm going to have my NH3. And I can already tell, well, let's just do this first and just to be sure. So this is 0.00133 moles. Remember, this has got to be moles. Just write them in. Now for the weak base, we're going to figure out we have same thing. We're going to cut it in half because, again, it's a half a liter. So 0.0212 moles. And it looks like I've got a lot more of the weak base than I do the strong acid. So the strong acid is going to neutralize some of the base and leave some of its conjugate acid. And its conjugate acid in this case is NH4+, right? Because you add a hydrogen to that. So NH4+ is our conjugate acid for NH3. Initially, we've got none. We're going to take the HCl, right? That's all going to go away. That's all going to be reacted. So our change is this. This is also this. And then, of course, this is going to gain that much because that comes from that neutralization. Okay, so we're going to do a little math. And this is pretty straightforward. We're going to have none of the acid left. It's completely been used up, neutralizing some of this weak base. And the base that's left is, do a little subtraction. We get 0.01987, good year. And then, of course, we have the conjugate acid, and it's just what we produced from that neutralization reaction. So that's moles, right? And our total quantity now is a liter because we took a half a liter of this and a half a liter of this. So now we've got a whole liter. So that makes our concentrations easier to figure out. So this is our concentration because it's just divided by 1 liter. So 0.0187 is our concentration of ammonia, and 0.0133 is our concentration, right? Molar is our concentration of the conjugate acid, the NH4+, the ammonium ion. So we have Kb of NH3. We can turn that into Kh of NH4+, right? Remember, you can do this thing, Kw equals Ka times Kb. And so that means that we can take Kw over Kb, and that'll give us Ka. And Kw, of course, is 1 times 10 to the negative 14th. And our Kb is right here. It's 1.8 times 10 to the negative 5th. And so that gives us a value of 5.55, let's just say 6 times 10 to the negative 10th. Woo, running out of room over there. That's times 10 to the negative 10th. And that's going to be our Ka of the NH4, right? The NH4+. Okay, so we've got our Ka here that we figured out. And we're going to use our old friend David Hasselhoff. Find the pH is equal to the pKa plus the log of the concentration of the conjugate base over the acid. Now, we could have done this with to find the pOH. That's another way to do it, and that's fine. You'll get the same answer. It doesn't matter. I'm going to go ahead and show you this way. So in this case, our acid is the NH4+, and this is the conjugate base. It's NH3 because we flipped this thing around to get the Ka. Look at how small that is. None of that should be surprising. We're going to get a big pH because this is mostly ammonia. So our pH is going to be high because this is mostly ammonia, which is a base. So our pH is equal to our pKa, which is going to be, so I'm going to take this guy, negative log of 5.5556 times 10 to the negative 10th, and that'll get me 9.2553-ish. Plus, we need to find the log of, from our Baca table, right? So the conjugate base, again, is, in this case, the ammonia, so the NH3. So that value is 0.01987, and the other value is 0.00133. That's our concentration of ammonium, right? Because that's our conjugate, or sorry, that's our acid, and that's our conjugate base. We just kind of flipped it. So anyway, this is going to be 9.2553 plus, we'll get about 1.1743, I believe, when you calculate all that out. You do the division, and then you take the log of that value. And that'll get you about, let's see, I see 3 sig figs everywhere. Yeah, 3 sig figs is good. So from our data, so 10.4 is going to be our pH. And that's what the question asked for, so that's our final answer. Okay, now we're ready for number 27. Pause the video, go ahead and do it. Actually, watch out for this guy right here. Don't forget that guy. Now, pause the video and go ahead and solve the problem. Don't just watch this through. Solve these problems before you see me do it. Pause it. Just pause it, Phillips. Do it. Moving on to number 27. We need to ask ourselves those same questions. Do we have strong acids? Do we have weak acids? Strong base, weak base? And which is in excess. So let's take a look here. It looks like we've got barium hydroxide. Of course, hydroxides of groups 1 and 2 are, especially the big ones, are always going to be strong bases. So this is a strong base. Be careful of that little 2. That's going to be problematic here. And then I've got, I'm adding this solid to 1 liter of this 0.01 molar solution of hydrocyanic acid. And, well, you know what? This is why you want to start with a Chewbacca table every time. I think it's not a bad idea every time to at least help you start thinking about this properly, to put a Chewbacca table in here. And remember that the Chewbacca table is always in moles. It's raining men. So let's put our hydroxide here because we've got to be careful of that too. And we'll just go ahead and put HC in here. And we don't, well, let's see. Well, the conjugate base is this cyanide, right, ion. So we'll let that sit. We may or may not need it. So if I've got 0.00840 moles of barium hydroxide, the actual hydroxide is twice that because there's 2 hydroxides for every mole of barium hydroxide. So when I get to, that's why I want to put the actual hydroxide here. So to find our actual moles of hydroxide, we take this and multiply it by 2, that 2 right there. And that gets us 0.0168. Is that right? 1680. I guess I got a 0 on there because I got sig figs. I'm just doubling that, so 16 and 80. That works. How much of this? I've got 0.0100 and none of that to begin with. So now that we've done that, we can see that we are actually in excess of the base. So we have a strong base here. We have it in excess. It's going to neutralize that acid, and we don't have to worry about it. We'll just calculate the pOH based on what's left of that strong base. So this is going to be minus 0.0100. This is going to be minus 0.0100. And if we want, this will be plus 0.0100. But we're not going to worry about this because this is a very weak base, right? So this little 0.01 of an extremely weak base, I'm going to have excess of a strong base. That's all that's going to affect the pH. So do a little subtraction. This should be pretty easy. This is going to be 0.00680 because we just took out that 1. That's going to be nothing. So now all I have to do is I have to find my pOH, and that's going to be equal to the negative log of 0.00680, and that's equal to 2.1675, blah, blah, blah. And so to find the pH, which is what I'm here for, that's going to be 14 minus my 2.1675 equals. And so that's going to be about 11. When I go to sig figs, looks like 3. For all my data, I have 3 sig figs, so we'll say 11.8. That's my pH. Now we're ready to do number 28. So pause the video, see if you can do it on your own. You should be able to. If not, play just a little bit until you get enough to get the ball rolling. I don't think this one's a very hard one, though. Let's take a quick look. I've got 5 liters. Well, that's a lot. I got 5 liters of this HI and hydrogen. That's hydroionic acid. That is that's strong. It's very strong. That conjugate base, that iodide ion, is very, very stable. Big atom, small charge. So very stable. That makes that a very strong acid. This is lithium hydroxide. That's generally considered to be a strong base, but if you look, I mean, technically, it is a weak base. It's less that has a K value of less than 1, a Kb of less than 1. So that makes it a weak base, but it's a very strong weak base, and it often gets lumped in as a strong base. Don't worry too much about that. We don't actually need the Kb because you can already see these are just, you're going to get 1 hydroxide, you're going to get 1 hydrogen. So in 1-to-1 ratio, we've got more of the strong acid. So, but to go ahead and do the Chewbacca table, because it just seems like a good idea. Our acid and our base. So I've got 5 liters of this 0.00200 molar solution. So 5 times 0.002, that gets me 0.0100. That's the, remember, it's moles, write them in. And then 5 liters of 0.0132. So that means I got to take 5 times 0.0132, which works out to be 0.00660. And from this, I can see I have excess of this hydronium, so I've got more acid. I'm going to neutralize all of the lithium hydroxide. Right, so I don't care about the Kb or anything like that. I don't care about the conjugate. None of that matters because I'm just neutralizing. So all I have to do is subtract. So minus the lesser one, which is this guy, minus here. Oops, 660. And that's 0. And this is 0.0034. 0, actually. And so to find the pH, easy. This is an acid, so the pH is just the negative log of the concentration of the hydroxide ion, or hydronium ion, and so that's 0.00340, and that equals about 2.47. That's my pH. So pretty easy for number 28 there. So those 3 problems, like the hard part is not the calculation, it's figuring out what calculations need to be done. We're going to do the same thing with the next 3 problems. If you want to take a crack at them before the next video, go ahead. So I hope you guys are doing well. Miss you. And we'll see you tomorrow.